Hello everyone, this is Revathi M, Assistant Professor, Department of Computer Science, Artificial Intelligence and Data Science, Dr. SNS Rajalakshmi College of Arts and Science. In this series, we are discussing about what is clustering, where we are using clustering, what are the advantages and disadvantages of clustering. Then second presentation, we seen about the K-mean algorithm. So in K-mean algorithm, how it works and what are the, where we are using the K-mean algorithm, how we are using. So these are the last session we seen about. Today we are going to discuss about the introduction to cluster validation. So in cluster validation, till now we have learned how clustering algorithm like came in from groups, but forming cluster is not the final step. We must verify whether those clusters are meaningful or useful. This process is called cluster validation. So cluster validation help us answer important questions such as, are the data points inside a cluster really similar? Are different clusters clearly separated? Can we trust these clusters for decision making? Without validation, clustering results may look correct visually but may not represent real pattern. Therefore, validation is essential to ensure the quality, reliability and usefulness of clustering outcomes. So these are all the introduction to clustering validations. It helps assess quality of clusters, results it is a meaningful or not, and discover the patterns, its robustness of cluster solutions. So the type of validation measures. There is no single method to validate clusters. So we use different validation approaches depending on this situation. Broadly, cluster validation methods are divided into three types. One is the internal, external and relative. These are the clustering validation types. In internal measures, it evaluates clustering using only the data itself. It's based on the data, compactness and separation. So they clustering the level data itself. In external measures, compare clustering result with known labels. In relative measures, compares multiple clustering results. That means multiple clustering solutions. So each type gives us different viewpoint. Sometimes one method is not enough. So we combine the multiple validation methods to get a clear pictures. So these are all the validation methods we are using in the clustering validation. Next, we see the internal measures. Yeah, so we will see one by one. In internal validation, what we are using, how it works, we will see one by one. First, it measures examine how well the clusters are formed internally without using any internal information. So, Silhouette coefficient evaluates similarly within clusters. How close a data point is to its own cluster compared to other clusters. The higher value means better clustering. Davis Baldwin index. It measures the cluster separation. It checks how similar clusters are to each other. Lower values indicates better separations. Next one is the Kalinskaya and Harabsk index compares variances. Here we compare the variances. So between clusters and within clusters, higher values mean well-defined clusters. Last one is a Dunn index. It evaluates the index in inter and intra-cluster distances. This measures mainly focus on compactness and separation, which are key goal of clustering. Next, we see the advantage of internal measures. Internal measures have several practical advantages. The most important one is that they do not require true labels. In real world data, labels are often unavailable. So internal measures become very useful. They are easy to compute, suitable for exploratory data analysis and helpful in deciding the number of clusters, widely used in supervised learning task. That's why internal measures are commonly applied in research and industry problems. So no external informations, unreliable data, ground truth and computational simplicities. Next, we see the external measures. So external validation methods are used when we already know the correct class labels. They compare clustering result with this ground truth purity measures how many data points in a cluster belong to the same class. So RAND index checks whether data points passed are correctly grouped. Adjusted RAND index improves RAND index by removing random chance effects. Normalized mutual information measures how much information is shared between true labels and cluster labels. External measures are very useful for benchmarking and academic evaluations. Next, we see the relative measures. The third one is the relative measures. It helps us compare multiple clustering results, comparing from the different algorithms. For example, k-mean with different values of k. Different clustering algorithm, different distance matrices by comparing validation scores. We can choose the best clustering configuration. Relative measures are especially helpful during model selection and parameter tuning. So we come to the end of this session. To conclude, cluster validation is a crucial step in clustering analysis. It ensures that the pattern we discovered are reliable and meaningful. Internal measures are useful when labels are unavailable. External measures are used when ground truth exists. Relative measures helps compare different clustering solutions. By combining these methods, we achieve stronger and more confident clustering evaluation, making our analysis more trustworthy. I hope